So today we are going to learn about conditional probability. So this is the knowledge, our learning intention is to gain the knowledge of conditional probability and when to apply it. So we'll be successful if we can identify an experiment which applies a conditional state situation and use the formula. The probability of A given B is probability A intersected with B and over the probability of B. And if we can calculate probability based on conditions. Okay. So, let's start. From our glossary, it states conditional probability. The probability that an event A occurs can change if it becomes known that the other event B has occurred. The new probability is known as conditional probability and is written as P, open bracket, A straight line B, right? And we can read this out as it's the probability of A given that B has occurred. That's how we read it out. If B has occurred, the sample space is reduced by discarding all outcomes that are not in the event B. So, for example, if I had a Venn diagram, and I wanted to figure out, so this is A, and that's B, and I want to figure out what's the probability of A given that B has happened. So if B has to happen first, that's all of this part. Well, for A to occur, I only have this bit in here. Yeah, so so my sample space is reduced by this. This has to happen first, leaving me only this part left. Okay. So let's look at some examples. The formula of the probability A given B is basically the probability of A and B, or the intersection of A and B, over the probability of B. Yeah, so this sample space, this amount over what has happened first. If you had it the other way, the probability of B occurring given that A has occurred, it's the intersection, which is still A and B, or B and A, the same intersection, over A. Okay, let's do some examples. A group of 30 people chose either to purchase the Daily Telegraph, let's call that event A, or the Financial Review, let's call that event B. If 15 people only purchased the Daily Telegraph, and 6 people purchased both newspapers, so that's the intersection. Alright, so there's 30 people, so 15 plus 6 is 21, so I should have 9 people purchase only the Financial Review. We want to find the probability that a person chosen at random purchased the Daily Telegraph. Okay, well that's all of this, so that's 21 over the 30 that we had. Okay, if we wanted to purchase both, okay, so that's the intersection. Yep, so we've got 6 over 30, which is 1/5. Purchase the Daily Telegraph given that they bought the Financial Review. Okay, so we want the probability that A has occurred given that B has happened. Alright, as I said, that's the intersection of both given that B has occurred. So the intersection here is 6. And given that B has occurred, so 6 plus 9 is 15. Alright, and that's how you work it out. So we're going to purchase financial review, that's B, given that they bought the Daily Telegraph, given A. Alright, so that's this. So we can go the intersection of B and A over the probability of A. So that's going to be 6 over 21. Okay. Alright. So other ways they could give it to you, they could give it, so that was obviously an example using a Venn diagram. So that was an example given a Venn diagram, and here is an example using a table instead. Okay, the table shows the results of a survey of city and country students who skateboard. So here we can see there was 272 city students who skateboard, where there's 163 city people that didn't skateboard were surveyed. Okay, so we want to find the probability that a person skateboards. So these are the totals. So we can tell that there was 660 people, students surveyed all up. So we want to find the probability that a person skateboards. So that is 422 over 660. Okay. We want to find, I'm going to use the word symbol S for skateboards. Given that the person is from the country, I'm going to say CO for country. Alright, so the person skateboard, given that they're from the country. So they've got to come from the country first. So I've got 225 people come from the country, and they skateboard. So I have 150 over 225. Okay. The next one. We want to find a person random that's from the country, given that they do not skateboard. I'll use that D as. So they are from the country, but they do not skateboard. So we need to find the do not skateboard first. That's 238, and they're from the country. That's 75 over 238. So that, given that they don't skate, they've got to come from the country. All right. Now we want to find the probability that they skateboard, given that they are from the city. Okay. So given that they're from the city, that they skate. So I've got 272 over 435. So notice that the given that they are from is the first thing that I look at, and then I get the other part. Okay. All right, let's do another question. So in a certain population, 37% of people have black hair, and 55% have brown hairs, and 10% have black hair. So let's say event A is black hair, and that was 37%. Let's say event B, brown eyes. That was 55%. So the intersection, black hair and brown eyes, was 10%, 0.1. Okay. Find the probability if a person is chosen at random that they have black hair. That's A. Given that they have brown eyes. Given that B. Okay. So remember that's the intersection divided by probability of B. So we get 0.1 divided by 0.55. 0.1 over 0.55. Okay, and it's 18, so I'm going to have 80% to the nearest percent. Okay. Now we've got the probability they have brown eyes, given that they have black hair. Well, that's the intersection again, divided by the probability of having black hair. So we get 0.1 all over 0.37. I want it as a percentage, so 27% to the nearest percent. Okay. So here's an important part. Independent events. If we have the probability of A occurring given B happening and they are independent events, well, it must come to terms that then it's going to be the probability of A occurring, because the fact that B occurs should not impact the event that A occurs, because they're independent. So as the impact of event B occurring does not impact the event A, then given, if it occurs, leaves only the probability of A. So let's look at this. If we have the probability of A given B, and we've noticed that that's the formula of the intersection divided by B, if I was to rearrange it, I get multiply both sides by probability of B, I get PB over probability of A given B is equal to the intersection. Well, if they're independent events, the intersection is just the product rule. Okay? So if I divide both sides by probability of B, it gives me that the probability of A given B equals probability of A. Okay. Let's do some examples. And these are, you might want to jot these down. These are quite good to remember. Okay, so the intersection is probability of A, probability of B. Probability of B given A is just probability of B, and probability of A given B is probability of A, and that's for independent events. So let's look at this example. Let's have two dice. We throw, let the first throw be an odd number. So that's, I did rows first. So that's that row, this row, and that row. The second number being 4, 5, and 6. So this is B. And the sum is less than 5. That's these numbers here. Okay. So if I was to calculate, the probability of A occurring. So I've got basically 6, 12, 18 over 36. Probability of B occurring is the same, 18 over 36. And the probability of C occurring is 6 over 36. Okay. Now, I'm going to find the probability of A intersection with B. So basically it is the first throw, and then the second number is 4, 5, 6. Well, that includes this one here. So basically these three, this is the intersection, and these three. So that's 9 over 36. So now we want B intersected with C. So we've got these ones, and then they add up to the sum is added up less than 5. Well, that's 0 because they don't there's no overlap. And now we want C intersected with A, or the A intersected with C. And so that's basically this one those 4. So we've got 4 over 36. Alright. Now, let's see what happens. Let's see if we got the probability of A given B. Okay, well, that's going to be the intersection of A over B over the probability of B. So the intersection was 9 over 36 divided by, which is the same as times in, flip that over, 36 over 18. Gives us 9 over 18, which is a half. Okay. Alright. Let us look at the probability of B given C. So that's the intersection over C. Okay. So the intersection is 0 over 6 over 36, which is still going to give us 0. Now let's do the probability of C given A. So that's the intersection over A. So we get 4 over 36. Flip that over, 36 over 18 gives us 4 over 18, which is 2 over 9. Okay, now I just want you to note, so 18 over 36 is the same as a half, obviously. Okay, so when I said the probability of A, so throwing an odd number, given that the second number is 4, 5, 6, that was a half. And notice that the probability of A given that B occurs is actually equal to the probability of A occurring. So we actually know that this situation is an independent experiment. These are independent events. Yeah, because the probability of A given B resulted in the probability of A. Yeah, throwing an odd number doesn't impact throwing the second number being 4, 5, or 6. Okay. So knowing this condition could help us with answering questions like this. So if we have a probability of A being 0.4 and the probability of B being 0.6, and we want to find the probability of A union B if event A and B are independent. Okay, so if they are independent, we note that the probability of A given B is the probability of A and B over the probability of B. Yep. Which means that because it states that the events are independent, we could use this situation. The probability of A given B is the probability of A. This is this, and all I'm going to do is substitute this part into here. Okay. I'm going to multiply out, so I've got the probability of P, A, and B is the probability of A, probability of B. So I'm using this identity, okay? So if that's 0.4, I'm going to times it by 0.6, gives us 0.24. Now if I want to find the probability of the union, I'm going to use the addition rule. That the probability of A plus the probability of B minus the probability of the intersection will give me the solution. So 0.4 plus 0.6 minus 0.24. So the probability of the union occurring is 0.76. Alright. Same kind of idea here, it's exactly the same. So now we've got the probability of A being 0.6 and the probability of B being 0.3. We want to find the union. Well, probability of A intersect with B is PA multiplied by PB. Probability of A, so 0.6 times 0.3 is 0.18. The probability of the union occurring, is the probability of A occurring plus the probability of B occurring minus the intersection. Gives me a solution of 0.72. Okay, and that's it. Thank you very much and good luck.